Today we're going to start learning about the Unit 9 vocabulary. Our first vocab word is proportional. An equation that states that two ratios are equivalent are proportional or a proportion. So our first set of ratios are written in fraction form, and we can see that they are equivalent or proportional. My numerator is multiplied by 4 to get my new numerator. My denominator multiplied by 4, the same number, to get my denominator. Another example of a proportion, we have 1/3 or 1/3 and 2/6. Another way we can check for proportionality, if we can't multiply by any obvious whole number, is to multiply across. 3 times 2 is 6, and 6 times 1 is also 6. Because 6 is equal to 6, we know this is also proportional. Non-proportional is when two ratios are not equivalent. Here's an example of two non-equivalent ratios, 2/3 and 4/12. In our numerator, we're multiplying by 2 to get to 4. However, in our denominator, we're multiplying by 4 to get to 12. Because we did not multiply by the same number, they are not proportional. If we used this method and got two different numbers when we multiplied across, that would also be non-proportional. Our next vocab word is constant of proportionality, or K. A constant ratio of two variables related proportionally. To find the constant of proportionality, we use the equation K equals y divided by x. So looking at this table, we would look at the 2 and the 1. So we have y divided by x, or 2 divided by 1, which is 2. So this is saying K equals 2. But I can't assume that until I've checked my entire table, unless they tell me that it is a proportional relationship. So looking at my next set, we have 4 and 2. My y divided by my x. Well, 4 divided by 2 is also 2. And lastly, 10 divided by 5, which is also 2. So we can say that this is in fact a proportional relationship, and that our constant of proportionality, or K, is equal to 2. Our next word is scale factor. The constant of proportionality, K, that is used to enlarge or reduce a figure, which we will talk about in a few minutes. So in this case, to find our scale factor, we use new divided by original. My new figure has a dimension or a side length of 4. My original has a side length of 8. 4 divided by 8 is 1/2. So my scale factor is 1/2 for this example. In that last example, we were looking at the dimensions of the triangles. So dimensions are the lengths of sides of a geometric figure. We have a triangle here. This is an isosceles triangle because two sides are the same length. We can show that they're the same length with this little dash. So they could have not labeled right here, and we would still know that this was a side length of 8. Because these side lengths are the same, we also know that these angle measures here are the same. Over here we have a rectangle. So again, if this is 2, they can show me that this is in fact a rectangle by showing me the other dimension here is also 2 with the dash, and a length of 4 here, dimensions. Our next vocab word is similar figures. Figures that have the same shape, but not necessarily the same size, are similar figures. So we have this emoji here. A similar figure to this emoji, well, this emoji is the same picture. They are similar, same shape, but they're not the same size. One has been reduced. A dilation, a proportional reduction or enlargement of a figure, is a dilation. So a dilation, again, it's the same shape, but not necessarily the same size. An example are your pupils. When you look into the light, your pupils change sizes. They don't change shapes. They're circles. They don't all of a sudden become triangles, but they change size. Another example of a dilation is zooming in on something, right? In CSI crime shows, they might show a fingerprint. When they zoom in, the fingerprint doesn't change. It's still the same image. It's just a dilation of the original. In our last example, an architect might model a home that they're going to make. When they enlarge the figure, it's the same figure, just a different size. So a dilation of a figure may be an enlargement or a reduction. We're going to look first at an enlargement. An enlargement that makes a figure bigger without changing the shape. If it is an enlargement, it has a scale factor greater than 1. So looking here, we have dimensions or side lengths of 2 and 6, 3, and then they didn't tell us what this dimension here is, but we can find it. So if we set up, right, we're from one side to its corresponding side. Well, how did we get from the 2 to the 6? We multiplied by 3. So we can find this missing side length by multiplying our 3 by 3 to find that this has a side length of 9. Our scale factor is what we multiplied by. Again, because it got larger, we know our scale factor was greater than 1. In this case, our scale factor was 3. If we have a reduction is a transformation that makes the figure smaller without changing the shape. If it is a reduction, again, our scale factor has to be multiplication. So it must be that our scale factor was less than 1. And half my example is showing, but that's okay. My original figure, my scale factor, we have my new over my original. So we can do this with one side length because they're the same for both. My new 4 divided by my original 6. We get 2/3. So my scale factor was less than 1, which is why my image got smaller. It is a reduction or our figure was reduced.